Today we're gonna use some fresh blood in our mass transfer experience. But before we start, we need to know what's the meaning of the mass transfer anyway. Well, let's say hypothetically that we have a mass called A in attached with mass called B. We have a different mass with different concentrations in the same place. What do you think gonna happen? Exactly, they start to mix until they totally mix and get equilibrium state. So we can describe a mass transfer as it is transferring a components from the area which has a high concentration to the area which has a low concentration. So let's see how does that happen in real life. So all we need here is an injection with a fill of blood and a cup of water. After spilling some drops here, we can see the blood diffusing. The reason of that is a different concentration between them. We can describe the diffusion of blood into the water using this equation. Well, let's say what's gonna happen if we raise the temperature a little bit. After using hot water here, we can see the diffusion of blood into the water is higher. Well, let's compare the difference between the first and the second experiment.
Hi! After we saw the impact of hot and cold water on the blood diffusion, now we're gonna see the impact of the ice and high viscosity liquid on the blood diffusion. So let's get started. Here we have a piece of ice and fresh blood. We're gonna add some blood drops on the ice surface, and as you can see, the blood will almost freeze after a few seconds on the ice surface, and diffusivity is almost non-existent. It's because of the low temperature and the solid surface of the ice. Now, let's see the effect of honey, which, as I said before, it's a liquid with high viscosity on the blood diffusion. As you can see, the diffusion of the blood is gonna be really slow due to the high concentration of the honey. After 2 minutes, you can notice that the diffusion stops at a certain limit, and it's lumpy and takes up just a little space. Now we can predict the blood diffusion from the following equation. And that's all we have today. Thanks for your time and thanks a lot for watching.